Hello everyone. For today's lesson, we will be covering slides 1 through 9 in your evolution notes, focusing on how the first cells came to be, and I will also briefly talk about the history and formation of the Earth. So I'm going to start here on slide 2. So let's talk about Earth's age. So Earth is about 4.5 billion years old, and that's pretty old. And this was determined using a method called radiometric dating, which I'll talk a little bit more about later. And it helps us to determine the age of usually rocks or fossils, and in this case, meteorites. So meteorites that were thought to have formed about the same time as the Earth. We determine the age of those, and then from there we're able to infer approximately the age of the Earth. How Earth was formed was by gravitational accumulation of dust and debris. So in space there was dust and debris, and over time they start to kind of clump together, and eventually we get this rock, which eventually will become the Earth. Now, looking more at Earth and its layers of rock, we refer to that as strata. We can study those rock layers and their composition, and like I talked about before, we looked at meteorites. We can also look at these different layers of rock and determine their age, and we can also look at any fossilized organisms within those layers of rock to help give us a better idea of Earth's history. Of course, the oldest layers being on the bottom and the newest layers being on the top. I do have a brief video to show you that will just put into perspective Earth's history, and it is broken down into 3.5 minutes. Start at the beginning here. So I really like that video because I think it puts everything into perspective in terms of how old the Earth is. And in terms of humans being here, we have only been here for a fraction of that time in terms of since the Earth was first formed. So if you want to watch that video again, the link for it is under helpful videos. It is the second video right here. So now that we've talked a little bit about Earth's formation and history, before I get to the first cells, I do want to go back to radiometric dating and briefly talk about what that is. So we use this to determine the age of rocks and fossils and even things like meteorites. Now, radiometric dating is a technique that uses natural decay rate of unstable isotopes found in certain materials. So there are certain elements that will decay over time, and we know what that rate of decay is. We know how long that takes. So we can look at a substance that has decayed, a rock or a fossil, and we can measure how much of that has decayed in order to determine a very specific age. Now let's start talking about the first cells. This is our main focus for today. So the first cells that formed on Earth were most likely heterotrophic prokaryotes. So heterotrophic meaning that they had to acquire their food by obtaining it somehow, eating it, and they could not make their own food. They are prokaryotes, so they are single-celled organisms that don't have a nucleus or membrane-bound organelles. So they are very, very simple, and they have no nucleus. Now, these cells were most likely some type of bacteria that were anaerobic, because at this point in time in Earth's history, there is no atmosphere, there is no oxygen. And again, as I said, they are heterotrophic, meaning they have to eat, obtain their food, and specifically they get that from organic molecules. However, over time, the food supply starts to run low. Now this instills an environmental pressure, so evolution and natural selection can take place. We'll talk more about natural selection later, but in order for evolution to occur, there has to be some sort of environmental pressure. In this situation, there's an environmental pressure in terms of food running out and competition for food. So this allows for us to get the first autotrophs. Now remember, autotrophs, these are things that can make their own food. Really good examples of these that you are already familiar with are plants. However, we're not quite to the stage where we have the first plants quite yet. And these autotrophs were most likely aquatic, meaning they were in Earth's early oceans. So if these are not plants that are autotrophic, well, what are they doing to make their own food? So these autotrophic prokaryotes are not doing photosynthesis quite yet. We will get to that eventually. Rather, they're carrying out a process called chemiosynthesis. And this is a process of using organic molecules such as carbon dioxide and inorganic molecules such as sulfur instead of sunlight to make their own food and energy. Now, these cells were most likely, again, they're prokaryotes, they're bacteria, but in particular, they are archaea bacteria. Now, this type of bacteria you can still find today. It thrives in very extreme environments, so where it's very hot, very acidic, or very salty. So an example is in the oceans near really hot thermal vents, you can find this type of bacteria. So we have prokaryotes, so again, very simple bacteria that are autotrophic, that are able to make their own food and energy using this process called chemiosynthesis. Eventually, though, we are going to get photosynthetic prokaryotes. So these cells can now do photosynthesis. They're using the sunlight's energy to make their own food and energy. So these prokaryotes were specifically called cyanobacteria. So cyanobacteria, these type of photosynthetic organisms, their fossils date back 3.5 billion years. So this is about 1 billion years after Earth has formed. So it's taken us a very long time just to get to this point where we have photosynthetic organisms. Now, this is super important because a product of photosynthesis is oxygen gas, which we often abbreviate as O2. Now, this is important not just for the organisms that we have on Earth in the moment, but also when oxygen gas reacts with UV radiation, UV light from the sun, it actually helps us to create O3, which is ozone. So this is actually helping to form the ozone layer of Earth and thus our atmosphere. So now that we have oxygen in the atmosphere, we have aerobic prokaryotes. Remember previously I said we had anaerobic prokaryotes because there was no oxygen. Well, now we can have aerobic prokaryotes because there is oxygen present. So we are not quite there yet to eukaryotic cells. I've been just talking about prokaryotic cells, which are very simple cells, things like bacteria. Eukaryotic cells, which is the type of cells that make us up, are much more complex. And I will talk about how we get from these prokaryotic cells to these eukaryotic cells in the next video.